Our project statement is to develop a system that receives plastic filament from an extruder, maintains a uniform diameter and temperature of the filament, and winds the filament into a usable form for a three-dimensional printer.
Our filament winder system had three main objectives. The first was to maintain a filament diameter for the industry standard of 1.75 millimeters with a tolerance of plus or minus 0.05 millimeters. The second was to wind our filament in a way to minimize the number of tangles on the spool so that it is ready to use for 3D printing. And our third objective was to develop a diameter feedback system.
Constraints for the project are including but not limited to a budget of $200 for ordering parts, though this was not inclusive of parts that were scavenged off of CTLM and individuals bringing in their own components such as the Arduinos. Power input was limited to a standard wall outlet of 120 volts and 1000 watts. It also had to be less than 30 pounds weight within a 2x2 by 3 foot dimension so a single person could place it upon a desk and move it themselves.
So here's our full filament winder system. We have the computer cooling fans up front. They're controlled by this switch and run off their own voltage power source from the AC/DC supply below and a voltage converter. Here's our diameter measurement. You can see we have the string running through bushings. Here's our servo motor. It'll move back and forth on its track to help wind up along the spool. You can see the motion. It's pretty slow, but it'll change in course with the speed of the spool. Here's the back of our diameter measurement. It's connected to a tire pressure gauge so that the change in the position of the bushing results in a change in diameter. It outputs to the serial monitor currently on the computer, so we can read the adjustments off of the serial monitor and then adjust the speed of the spool. Here's our pulley system with the spool. It's connected to a potentiometer to change the speed according to the diameter of the filament. You can see it slow up and speed down as we twist the potentiometer. The motor we're using is a NEMA 23 and it's attached to 2 pinions and a pulley. Here are our electronics. We have 2 voltage converters connected to a 24 volt AC/DC supply. We also have a TB6600 stepper driver.
After developing our prototype and observing it, the primary improvements that we can make in the future if we were given more time would be to machine more parts rather than 3D printing most of them. This would give the project more durability. It would also be beneficial if we could combine all of our code onto one Arduino board. We had some difficulty in getting the timing lined up for all the different components, so we broke the code into 2 different Arduino boards. And to develop a better way of accepting the filament from the extruder project, we had issues when connecting our winder project with the extruder group, so creating a better way to do that. Also, having better organization of the components to allow the use of only one voltage converter. We used 2 in our project. It would save cost and space to only use one and simplify the project. These are our design improvements, but we were very satisfied in how our prototype turned out. And we were able to achieve every single one of our objectives, that it would maintain a diameter of 1.75 millimeters, it would wind the filament onto a spool, and it would provide a diameter feedback system.